Hello students, we are solving a question on system of particles and rotation. This is from 22nd January shift 2 JEE Mains 2026. The question says two masses small m and 2m are connected by a light string going over a pulley which is a disk of mass 30m and radius r is equal to 0.1 meter. The pulley is mounted on the vertical plane and is free to rotate about its axis. The 2m mass is released from rest and the speed when it descends through a height of 3.6 meter is something meter per second. We need to find what is the speed it will gain when it descends by a height of 3.6 meter. Now obviously here the pulley have mass, so tension on either side of the pulley will not be equal. We'll consider the right tension T1, left tension T2. For no slipping to occur at point P, the value of A, which is the acceleration with which the rope is going down over here, should be equal to the value of R alpha, which is the acceleration with which the pulley is rotating at this point. So A equal to R alpha. Next, if we apply laws of motion in the y direction on the mass 2m, you'll get 2mg minus T1 is equal to 2ma. Similarly, if we apply laws of motion on the mass small m, it's moving upwards, so T2 minus mg is equal to ma. Next, if we apply that the difference in the two tension is generating the torque for the pulley to rotate, we can apply tau equal to I alpha on the pulley. This will give you T1r minus T2r is equal to, pulley is a disk, so we can do capital Mr square by 2. The mass of the pulley is 30m, so 30m into r square by 2 into alpha can be written a by r. So interestingly, all the r values gets cancelled. That means the radius of the pulley doesn't matter itself. And we get T1 minus T2 as 15 ma. So now we have three equations. Let us add these three equations because T1 will get cancelled with minus T1 and minus T2 will get cancelled with plus T2 if we add all the three equations. So if we add them, we are going to be left with 2mg minus mg on LHS and 18 ma on RHS. This will give you the acceleration to be g by 18. It seems that the mass 2m is moving with constant acceleration. Since it's moving with constant acceleration, we'll apply v square is equal to u square plus 2as. But initially it is released from rest, so u is equal to 0. The speed v square is equal to 2 times acceleration is g by 18 into 3.6. On calculating, you get v square as 4 or speed as 2 meter per second after it has descended a height of 3.6 meters.